Alright, so basically, we're going to do 2 word problems, and essentially what's going to happen is that on, like, a quiz or a test, those 2 word problems that we do are, like, just, like, copied and pasted if they're there. Maybe, I mean, numbers might be changed, but, like, those are the only 2 problems. So you're not going to actually have any that you have to do because we're doing odd ones just because they're better. Like, the even ones just aren't good. So, anyways, just make sure you understand how to do them, like, once we go over them. But you won't, I might add, like, 1 or 2 more problems to what you had, but you won't really get a word problem that's added to it. Well, I put them on YouTube, so. Alright. So 35 is the first one we're going to look at. Okay, and it is a minimizing perimeter problem. It says, consider all rectangles with an area of 182 feet squared. Let x be the length of one side of such a rectangle, and then the part that we're going to do is to express the perimeter P as a function of x. Okay, we know that the length of one of the sides is x. Okay, and what do we know about the area of a rectangle? It's length times width, so A is equal to L times, we're going to call it x. So the other side would be what? Okay, yes, but I need to know, like, numbers. I need everything in terms of x and numbers. Yes, so we know that the area is 182. Okay, and we know, well, we are given x, so we need the other side is 182 over x. Okay, so to express the perimeter P as a function of x, so I actually really want to know perimeter, and what is the formula for perimeter of a rectangle? Okay, so we have our x, and we have 182 over x, so basically, now I'm just plugging them in. Huh? Well, I want to know what the actual perimeter is, so I need to simplify this. A P. Yeah. Technically, we have 2 unknown things, so we really need to figure out what x is going to be equal to, because otherwise, I mean, right now we don't have enough information to really do anything. But, yes, getting a common denominator, so how do I do that? So you're on... I mean, technically we want to know what the actual perimeter is. Hold on, let me check one thing really quick, because I need to make sure, because I have this being a square, so I need to check it and make sure that it's right. Well, it says, like, the problem says it's a rectangle, but the answer that I have written down says it's supposed to be a square, so I'm trying to make sure that that's right before we keep going. Oh, wait, we're not doing that part. Sorry, I was getting ahead of myself. Yes, we can, well, you can either leave it here or here is fine. Whoa. I was working on part B, but I'm not going to have you guys do part B. Basically, for the finding the dimensions of it, that's why I was like, wait a second. You would just need to plug it in your calculator and do the max-min stuff to find it. This is minimizing, so you would want to find the min of the graph when you graph it, but we're not doing that part, so that was part B. So we would just stop, like I said, you can either stop here or here, it doesn't matter, but that's all that you would need to be able to do. Yeah, I typically would just leave it here instead of doing the extra work, but if you were to, like, get a common denominator and all that, that's fine. So, we're not doing the part B. That's what I was getting ahead of myself, because I don't have that labeled as part B over here on my paper. Huh? Alright, and then I think we're going to look at one more. Alright, we're going to look at 37. Alright, so this one, Drake Cannery will pack peaches in 0.5 liter cylindrical cans. Let X be the radius of the can in centimeters. Express the surface area S as a function of X. So, well, first of all, what we're given, 0.5 liter cylindrical can. We know that there's a radius of X, and that's in centimeters. Does anybody know how many cubic centimeters are in a liter? How many cubic centimeters are in a liter? One liter is equal to 1,000 cubic centimeters. So if I have a half-liter cylindrical can, how many centimeters cubed do I have? Okay, so this is the conversion I'm going to need here. Now my question is going to be, does anybody know the surface area for a cylindrical can? You're thinking of volume, I think. Okay, just to verify that we know what we're talking about here. Okay, we're talking about something that looks like this. So basically, I need the area of these two ends plus the area of all this outside stuff here. Okay, so Well, what? Okay. So what is this? The bottom and top are what? What is the area of a circle? Pi r squared. Okay. And how many of them do I have? Okay. So 2 pi r squared plus, now I need this extra stuff here. Okay. Technically speaking, this is still a circle all the way up. We just don't have the middle stuff. So we're not going to square it, and we're going to multiply it by the height. So it's going to be 2 pi r h. Okay. Now obviously, being that I'm giving you the 2 problems that you would need to know for a quiz or a test on, well, we're not testing on this, we're quizzing on this stuff. You would need to know this formula. Okay? Because I'm being nice and telling you ahead of time. So you're going to need to know that formula, so make sure you know it. Okay? So I need to kind of convert things here to figure out all the pieces that I need to actually be able to express the surface area S as a function of x. So what do I know about the volume of this? What's the volume of a cylindrical can? Like, what's the formula for it? Okay, I didn't hear you. Okay, and we know that I heard somebody earlier say that this is equal to this 500 centimeters cubed, which is true. Okay, that's the volume. Okay, we're going to call our radius x. Okay, so down here, these r's are going to change to x's. And I need to get rid of this h. I need h written in terms of x. So I'm going to go ahead and change this r to an x here. Okay, so how do I get h by itself? Okay, so 500 over pi x squared. Now I can take this, and I'm going to plug it in for h over here. Okay. So S is equal to 2 pi x squared plus 2 pi x times 500 over pi x squared. Okay? So now what do I need to do? Over here? So I can get rid of an x. I can get rid of pi. So S is equal to 2 pi x squared plus 1,000 over x. Okay, I'm technically just looking for surface area, so if you want to leave it here, that's fine. If you want to get a common denominator, that's fine. But I would say just leave it there because I'm just looking for surface area. Okay, the next part of the problem, we're not going to do it, but just so you kind of are aware of it, because we do stuff similar to this in calculus, but we don't take this approach to doing the problem. Like, the first part, we do take this approach. But then the second part, we actually use calculus to find it, so we wouldn't do it this way. But it says, find the radius and height of the can if the surface area is 900 centimeters. So basically, all you would do is set it equal to 900, and then you'd have to solve for x, and then use x to solve this. So we could do it if we wanted to, but I'm not going to require that, okay? if you guys know how to solve the other problems, I trust that you would be able to do this. So I don't need to like spend time on it with the word problems. Okay. I'm not really gonna go over any more problems. But I am going to give you like 1 or 2 more to do. And then you'll just have the rest of the time to work on it and get everything done. And I'll make sure I have a tab up for it. So yesterday I think I gave you stuff like through 18. I mean, not technically all of those, but let's see. $25. And 29, I'm going to tell you, is going to give you some weird like decimal answers, so you can leave it as just like the fraction that you get when you solve it. Or if it requires you to use the quadratic formula, I'm not 100% sure just by looking at it if it will. But that one, you don't have to write the weird decimal answers. If you just simplify the quadratic formula or whatever you use for it. So those are the only 2 I'm going to add on, and then just make sure you understand the word problems. And like I would say, definitely before we take a quiz on this stuff, like make sure you rework the problems.